Ladies and gentlemen, thank you for standing by, and welcome to the SOI Global Community Webcast conference call. All lines have been placed on mute to prevent any background noise. After the speaker's remarks, there will be a question and answer session. If you would like to ask a question during this time, simply press star, then the number 1 on your telephone keypad. If you would like to withdraw your question, press the pound key. Thank you. I would now like to turn the call over to Stephen Sheldon, Community Board President. Sir, you may begin your conference.
Thank you. Hello, everyone. Welcome to our first SOI Community Webcast of 2015. I hope everyone's holidays went well. It's really nice seeing some of you at CA World in November. Now, in the past, we've done multiple topics in the webcast, but starting with this one, we're going to be trying to focus it in a little bit better. So we're just going to have a single topic here. And we've got a great presentation today, starting first with Kevin Meehan from CA, and then we're very lucky to have an SOI customer, Daniel Blanco from AlphaServe Technologies. Both of them are going to be discussing the UIM connector for SOI. And for those of you who haven't heard, Nimsoft was recently renamed to UIM. So we're all going to do our best to call it UIM, but you'll have to forgive us if we occasionally still call it Nimsoft. And since we have a lot of information to cover today, we're going to wait until the very end for questions. If you think of any during the presentation, feel free to use the Q&A panel, but please indicate if you're doing that who your question is for, whether it's Kevin or Daniel. And lastly, I recently posted a thread on the community about the webcasts, just asking general thoughts on them, ideas for the future, anything you'd like changed. So if you get a chance, please go on there and take a look at that. So, Kevin, it's all yours.
Great. Thanks, Stephen. So as Stephen mentioned, we're really excited today to share with you the UIM connector, which was referred to as Nimsoft. So this is a relatively new connector that was first introduced back in September. It went GA. And since then, it's been getting a lot of attention, and a lot of clients are seeing a lot of value in the integration between UIM and SOI. So the focus of today's presentation is really to show you what the connector is all about in terms of the functionality, what it offers, and I know we have a technical audience on this call, so really do a deep dive and explain how the connector works, what is exposed through UIM, how we use that data from UIM within SOI to create alerts, to create CIs and models, and really kind of give you the full picture. And Dan Blanco is on as well, and he'll talk about how he's using the UIM connector to add value to his SOI implementation, and then he's done some very nice work there. So as an agenda for the next hour, so we'll start off with an overview. I think that this invitation was extended to the Nimsoft community as well, so welcome to everyone from that community. I do realize that UIM may be new to some, so we'll start off with an overview for those in the SOI community that are not familiar with UIM. We'll talk about the architecture, and we'll talk about the data flow and the messaging model, which is very open and critical to how the connector integrates with UIM. And then we'll follow that with the connector overview. We'll talk about the installation requirements and walk through each requirement and each consideration, pre-consideration that needs to be made prior to the installation. And then we'll get into the nuts and bolts of the connector in terms of how do we create CIs within SOI from UIM? How do we get models? How do we model them? What information do we use to model them? And we'll do the same for alerts within SOI. How do we keep the synchronization up to date? How are alerts received and processed? And we'll actually look at the policy file itself and try to make that clear to you. And finally, we'll review some best practices, and I'll share with you the debugging that will hopefully be helpful to you should you want to enable debugging to troubleshoot or to do some customizations of your own. And then Dan will speak to how he's actually done some best practice customizations to add value to his implementation. Okay, so just very quickly, what is UIM? Well, UIM, Unified Infrastructure Management, is the renamed Nimsoft monitor. UIM is an extremely powerful It's a single united platform, unified, that provides end-to-end monitoring and control of your entire IT environment. And this is what really differentiates UIM from competitors. It really is a single unified platform, and by that I mean it enables monitoring end-to-end across domains of heterogeneous infrastructures. So we're able to monitor systems, networks, power, application, database, cloud, and we do that through the architecture that utilizes the probe infrastructure. So out of the box, UIM ships with over 150 what we call probes, and these are lightweight monitors. They're agents that sit on monitor devices. They can also operate agentless, and they're able to do monitoring of this information from various silos. And it's that plug-and-play probe architecture that really differentiates UIM and enables us to do quick on-demand delivery of monitoring, and with very easy extensibility. So we have an SDK that allows you, the customer, to easily write your own probes, and in that way, we can scale with time as well. We can scale with the future integrations. And the fourth bullet point, the message bus is also a big differentiator with UIM to other products. It enables UIM to be as highly scalable as it is. UIM has a distributed architecture, and we'll talk about that in the next slide, but you can easily scale out very quickly, very easily. The UIM UIM communication throughout the product is based on a message bus. So it's a publish and subscribe communication mechanism, and in that way, it's extremely fast. It's also secure. We have easy to set up VPN tunnels, and in the end, it's very simple. And from initial implementation to kind of you're up and running, it's very fast in terms of being able to quickly distribute policies to probes and get yourself up and monitoring and reporting fast. So it's also resilient and highly available. So it's TCP-based, so message delivery is reliable, and there's built-in failover capabilities, and we'll see that in the next slide. And it's excellent reporting through the portal. The portal is web-based. It offers up-to-date, intuitive views of what's being monitored, reporting, and it also offers multi-tenant capabilities. Okay, so just a look at the UIM architecture and components. So this is kind of a high-level look at the UIM architecture. And you can see right in the middle we have the hub. So the hub is central to the UIM architecture. And it's basically the message broker from which all alarms that come in from the probes that I mentioned about earlier are received and then distributed. And the hub is really central to the connector. The connector uses a Nimsoft API to communicate to the hub, and the hub will then share with it messages. But in focusing on the UIM architecture, we have the hub, which communicates to the message bus, which is a publish and subscribe message bus. And below that, we have the robots, which are very lightweight agents that reside on the systems that they are monitoring. They're also available to be agentless. So the robots, they think they take less than 1% of resources. They're less than 10 megs, and they control the underlying probes. And you can see that at the very bottom, there are probes that report into the robots that do the actual monitoring. And as I mentioned earlier, over 150 probes across silos, across domains that enable the monitoring of heterogeneous infrastructure environments. So if you just read kind of across the bottom, we have an SNMP probe that can go out and monitor network devices. We have the NMS probe. We have log file probe, the CDM probe, which is the CPU disk memory. So basically, if you have something, there's a probe for that. And if there isn't a probe for that, there's an SDK in which you can easily write a probe. So the probes communicate back up to the robots with their alarms, and the hub subscribes to receive those off the message bus. And this is a very simple architecture, but you can scale out hubs. So you can have a middle layer between the hub and robot that you can deploy intermediary hubs that in a multi-tenant environment, you may have a hub for each client. Hubs may be positioned geographically, so you can easily scale those out as well. I think a hub monitors roughly 5,000 robots. So, and then at the very top, the hub feeds performance reports through the UIM portal, and it also feeds the Nimsoft database. Okay, and in continuing to talk about the message bus, so at the very bottom level of the UIM architecture, I mentioned the probes. So if you look at this little diagram here, the probes will collect the QoS data and send that data to the robots in the form of a message. The robots will then spool those messages, and they will communicate those onto the hub. And now if the hub is not available, it will spool them and hold them for later retry. And in that way, the messaging is very reliable, and the robots do receive notification that their messages have been successfully sent. The hubs then will dispatch the messages to the database, and the hubs can also, the hub, again, is the message broker, so the hub will look to see who else subscribed to receive these messages, what other probes, and that can be the NAS probe. It can also be reporting or the UIM portal. And where the connector comes into play is, and you'll see in a moment, the connector subscribes to the hub to receive all its alarms. So the connector hooks into that message bus, and that's how we receive the alarms. So we use that subscribe mechanism. We leverage that, and then again, this message bus is what allows UIM to be so scalable, to be so fast, and we send a subscribe request to the hub, and I'll show you how we set that up in a moment. And then we receive messages matching the subjects that we subscribe to, and the connector subscribes to receive all new alarms, all closed alarms, all assigned to or updated alarms. So we'll subscribe to receive the alarms that we want. And there are two methods from which we can subscribe. We use the second, which I listed here, the attach. So what we'll do, and in a few screenshots we'll see this, is we create a queue within Nimsoft, within UIM, to hold the messages that we want the connector to receive. And once we connect that queue, once we create that queue, we'll subscribe to it and receive those messages. So if the SOI goes down, if the connector goes down, that queue will continue to hold those messages and spool them, so when the connector comes back up, they'll be sent over. So you can see in this diagram here, we have the UIM connector all the way on the left. There's a UIM robot that needs to be installed before the connector, and then we're plugged into the message bus. So then we're able to communicate to the hub, the primary hub, and the hub is basically all messages pass through the hub. So once we're connected in there, the connector will look at the catalyst queue, and we'll actually create that within UIM. We'll create a catalyst queue, and we can then pull in all the messages that get placed in that queue. So keys are just actually physical files that contain records. You can view those files, and messages are always stored in the queue files. And again, our connector I mentioned earlier subscribes to receive the following types of messages. So this is a subject-based subscription, and we'll receive all alarm new, alarm update, alarm closed, and alarm assigned. And here's just a screenshot of my hub probe. And if you click on the status tab, I can see all my queues that I have defined here. And here I have my catalyst queue. I could see my subjects that I subscribed to receive alarms from, and I can see on the very rightmost column, I can see the connection back to my connector, and here is where you can check to see that the queue is defined. There's a connection back to the connector. Okay, so I hope that was a good kind of overview of the architecture for those not too familiar with UIM. And now let's get into the actual connector. So UIM Connector 1.0.0.105 is now available. It's available through support.data.com download. And it was actually released, I think, back in September, and we have some updates coming up pretty soon. But so the CA UIM connector, so what does it do? So basically, it collects CIs and alerts from CA UIM. And how do we do that? And we'll get into this in a bit more depth, but the CIs are pulled from the UIM database. So we actually do a direct connection to the database in order to retrieve CIs or models, and we do that on a regular basis. So we do that every 1 minute. We're looking for any updates made to the database, and then we're retrieving them, and we're putting that information and that data through policy to create models within SOI. So the second half of that, well, we got the models. Next is the alerts. How do we get the alerts? Well, as we just talked about a second ago, we subscribe using the UIM API to the message bus, and we look at the Catalyst queue to receive all of our alerts. Once we get that raw data from UIM, it's processed and transformed to the common USM format through our connector policy. And the connector policy is not unlike other connector policies that you may have seen with SOI, very familiar. For those of you who are familiar with SOI connector policy, and I'll show it in a moment, very similar. So the policy is extensible. Most UIM alert attributes are exposed to SOI. So once you see the raw data, you'll see that we get information not only about the message, the severity level, we also get information as to what robot it came from, what hub, what domain, what NIM ID. So all those attributes are exposed to SOI, and they can be used to populate your own user attributes and used in other ways. We also have inbound connector operations that allow for alerts that are cleared within SOI to be cleared within UIM. So that's that southbound connector functionality that allows us to talk back to the domain manager or UIM. So here's a look at the connector architecture. And in the top left, we have our connector system. It runs on top of Catalyst, and this needs to be updated, but it's 3.4.1 is what we run the connector on. And on the right, we have our Nimsoft system, and basically you can see the JDBC connection that we make to the database to retrieve the computer systems and models, and then through the robot to connect into the message bus, we receive our alarms and communicate that back to the SOI manager. So we go through the ISW proxy to communicate back to SOI, and then we have the UCF broker to communicate back to do that southbound synchronization. Okay, and just to share some of the prerequisites and some things that you should know prior to an installation. This is just a listing of the operating system support. So the UIM connector supports the following: Catalyst container 3.4.1 using a file-based registry. So prior to the UIM connector installation, you need to install the Catalyst container. And these are the current UIM versions that we support, so 7.5, 7.6, 8, and most recently 8.1, which I believe was announced just last week. So we support all those versions, and we currently support the UIM running on the following databases: SQL 2012 and 2008 R2. And I believe that Oracle may be coming quite soon as well. The UIM connector supports installation on the following operating systems, and you can read here 2003, 2008, 2012, just things that are good to know. Okay, now getting into some of the pre-installation considerations. So in addition to the hardware, what needs to be done? Well, the first thing that needs to be done is to install the UIM robot on the target connector server. So again, the UIM robot, a component of the UIM architecture, and that's essential to allow us to plug into that message bus to receive the alarms and use the UIM API to do that. So UIM robot installation, again, robot is extremely lightweight, very quick install. The footprint is next to nothing. So the second thing to do is to verify that the Catalyst container is installed. The third thing, verify that the message queue is configured and enabled on the primary and secondary hub. And I'll show that in a moment, but you must create a Catalyst queue on the primary hub and on the secondary HA hub if you have a primary and secondary and failover set up in your UIM environment. So manually setting up that queue and calling a Catalyst and then subscribing to the proper subjects that I listed before. Remember, it was alarm new, close, assigned to. And fourthly, as a best practice, we just recommend that you install the connector on either the primary or secondary server or just the database server just to keep them separated. And then we'll also need read access to the Nimsoft database for querying for the CI and alarm information, and read-write access to the message queue configured in the primary and secondary hub. So, okay, configuring the message queue. So how do we do that? This is a screenshot of the UIM Infrastructure Manager UI, and this is the UI from which you can go in and configure probes and robots and basically your entire UIM infrastructure. So we want to configure the hub probe. Again, that's the probe through which all alerts pass and get routed. So we'll want to configure that, open that up. And we want to add a Catalyst queue, message queue to this. So clicking on the Queues tab, you can see I've done it here already, but I have a Catalyst queue. The type is attach, and attach, again, that means that the messages are stored, and even if the SOI connector is unavailable, they'll kind of queue up until it is available, and then SOI will read off of that queue. So the following subjects are added to that. We have alarm new, alarm update, alarm assigned, and alarm close, and that's really it. And here's a look at the edit of the queue, and you can see the parameters that have been filled out here. So that's really all that needs to be done on the Nimsoft side. Again, if you do have a secondary hub, you'd want to configure the HA probe and make sure the Catalyst queue is set up there as well. Okay, so we've installed the robot on the connector server. We've configured the message queue on the primary and secondary hubs with the Nimsoft. So I think we're ready to walk through the installation. So as a step-by-step, just to let you know what the installation looks like, double-clicking the setup.bat from the connector package launches the installation. We have the license agreement. And then here's where we specify the database credentials. So specify the database server, the database name, the port, and in this case, we currently support SQL. So we want to specify those database credentials, and again, we retrieve all our CIs through the database, through a direct connection to the database, and that's the method we use. Okay, and the next screen is configuring the primary hub and secondary if one exists, and specifying the username and password. So we want to specify the primary hub here and the secondary if there is one, username and password. One note, the username is case sensitive, so just something to note. And then we have the pre-installation summary, and that's about it. So the installation is pretty straightforward, pretty quick, and hopefully run successfully. And if it does not, we have some logging that you can review. I just wanted to mention that here. If you do have any errors or want to examine the installation any further, we have detailed logging that will show you every file and where it's in place and everything like that. Okay, so once the installation is completed, the UIM connector looks like any other connector within the SOI UI. You see in the left-hand pane, I've expanded my Catalyst connector server, and I have my UIM connector here. These are the default out-of-the-box settings. I haven't changed any of the connector controls here. So we have get CIs on at startup, perform delta processing. These should be familiar. You should be familiar with these, I think, if you have worked with other connectors in the past. Looking at the connection details, the connector code is 00050. Some things of interest may be the delete thread poll interval and the event delay. So I just want to point out some things that are different from other connectors. The delete thread poll interval is how often we go to the UIM database to look for deletes, and then we remove them from SOI, whereas the event delay, the property right below that with the value of 60,000, that's in milliseconds. That's how often we check for creates and updates from the UIM database. And we have the hub password below that and the username we use to connect to the primary hub and, through the message bus. We have the JDBC connection information here. The primary hub, the secondary hub, and supported CI types is computer system. The mock alarmed files in the mock mode, those are used for debugging purposes, so you don't really have to be concerned with those properties. Okay, and the connection details, this translates over to the Nimsoft connector.xml. So if you wanted to update the settings directly, you can do that through the Nimsoft connector.xml, which is in the modules directory. Okay, so one of the first places you might go after any connector installation to verify successful installation and successful CI retrieval is the modeler. Here's where we go, and we can make sure that the models came in to SOI successfully. We've made that connection to the domain manager, and we pulled them in and processed them successfully. So you see here that all the CIs are retrieved through that UIM database query, and the CIs are created of class computer system in this version. So all classes all models are either created as computer systems or generic IP, and that's in this release. We may be looking to get more granular in the future, but currently we're of the class computer system. So during the connector startup, this is the database query that we perform. So we just do a select from the CM_computer_system to retrieve all the models. And we do that query every minute. So every minute we'll do a callback to the database, and we'll do the same select statement but with a where clause to look for has it changed from this previous minute. Are there any updates? And to turn on debugging within the Nimsoft connector, you can do that through the Nimsoft connector-log4j.xml. So just to highlight the directory where you can find that file, and this is the whole file here, so just modify the value from info to debug. And what you'll get is more information in the Nimsoft connector log. So I just wanted to show an example of what you can see within the Nimsoft connector log, and here's a single CI import entry. And in this case, I've pulled in this computer system MEEKE02-2, and here are all the attributes from the UIM database, the raw attributes, and I wanted to show how we map those attributes to models within SOI. So if you look at this little chart here, we have the database property within UIM, and in the right column I have the USM CI attribute. So within the UIM database, there's the CS_ID. So that's the unique identifier of the device within UIM, and we map that to the MDR element ID within SOI. The MDR element ID is the unique identifier within SOI of a CI. So that's what we use there. We have a DB property for IP. Naturally, we map that to primary IPv4 address, DNS name to DNS name, OS type, OS name to primary OS type, name to computer system. So, there are some that are essential to the model creation, required attributes within SOI, and those required attributes are MDR element ID, and then we need the correlatable property, and we have the IPv4 address here. So I just wanted to kind of bring that to everybody's attention. Sometimes you wonder how do we populate DNS name, how do we populate IP, and this is how we do that. Okay. And looking at the, staying within the CI creation, looking at the Nimsoft Connector Policy .xml, I wanted to share this with you as well. Here's where we store the policy, and this is the directory path. And here's a look at the item event class. And the item event class within the connector policy is really the entry point within the connectors. So this is where, once we get that raw data, this is kind of the entry point, and then we route from there. So, this classify section, the first section in this policy file, this is how we route to the appropriate sub-event class. So the raw data comes in from UIM. We're going to examine the class property if there is one, and if it has a value of computer system or device, we're going to route it and create it as you can see the out value here, computer system class or a generic IP class based on the contents of that raw class property value that we pulled from the database. And the third line within the classify section, we'll look at the NS entity type. That's the value that comes over from Nimsoft, and it has, if we match on the pattern NS message, we know that it's not a CI, it's an alert, and we'll deal with that appropriately. The format section contains some information that is inherited by the subclasses being computer system and generic IP device. So these are common attributes across the subclasses, and we have that inheritance hierarchy. So we have some properties that are standard, across the connector, that being the connector ID, which is 00050, the first line, and the MDR product will be CA colon 00050, and we saw in the previous screenshot, we use the CSID as the MDR element ID, the IP as the primary IPv4 address. Okay, the policy file, you'll notice that it's not that big. It's pretty small. And just to look quickly at the computer system event class, you can see how we do the processing and creation of computer system models within SOI based on the information we get from Nimsoft. So we look at again, information that we retrieve from the database. We look at the OS type and OS name, and we map that to a primary OS type. And in the format section, we use the name to populate the computer name attribute, the MAC address to populate primary MAC address, and it's pretty straightforward. Okay, the UIM alarms. Now we just looked at how we create CIs or models within SOI. Let's go to the second half. How do we deal with alarms? So alarms are basically created within UIM from probes that monitor devices or systems or applications, and when a problem is found, the robot sends a message to the hub, and the hub will then route it accordingly based on who has subscribed to receive them. here's a look at the subconsole, the top picture. This is the subconsole, which is a Nimsoft UI, and we see the alerts as viewed within that. And the lower half, I just wanted to show the SOI Alert Console. And you see that what's in the message field and the UIM SubConsole, that's what we use to populate the summary field and the message field within SOI. And you can see that the severity levels are the same. So, you know, we do direct mappings, and they should look really no different. So, UIM alert processing. So the connector is subscribed to receive the UIM messages from the queue. We receive notifications of create, update, clear. And you can look at the 00050 XML files within the SOI event store to review the raw UIM alert properties that are received by the connector. And I just wanted to show that here, a quick screenshot, just to kind of let you know what raw attributes we get from UIM. So this is on the SOI side, this is the event store, and you can see that you know, I have my PRID, my hub, the level corresponds to severity. So this is raw information that I can do whatever I want with within my UIM Connector Policy. And like I showed you the CI mappings, I wanted to show you the UIM Alert to SOI Alert mappings. So the UIM Alert properties, summary to summary, message to message, the level corresponds to severity within SOI. So the levels are single value 0 to 5, and we'll look at that, and then we'll map that to a SOI severity level, normal, minor, major, severe. The NIM ID, like we saw the CS ID for the CIs, there's a NIM ID for every alert within UIM, and that's the unique identifier, and that's what we'll use as the unique identifier within SOI. That's what we'll use to populate the MDR element ID. Again, the CS ID, we use that to populate the alerted MDR element ID. And what is the alerted MDR element ID? Well, that's how we know where to place the alarm within SOI once it comes in. We need to attach it to a model. So we use the CSID, which corresponds to the CI's unique identifier. And then we have the occurrence timestamp and reported timestamp. So here's some additional exposed UIM alert properties that are exposed to SOI that we don't use within the policy, but you can definitely use them, and Dan's going to talk about how he uses them to kind of easily create alert queues and services within his environment. So just to let you know that we do share information like what hub, robot, PRID, subkey that or SID that the alert has come from. And here's a look at the alert event class, and this is the whole thing. So basically, like I mentioned earlier, you can see on the very top, we do a normalization where we examine the level property of the alert from Nimsoft. So you can see the input is level, and then the output is severity. And kind of the middle there is our mappings. So if a value is 1, it's informational, 2, it's minor, 3 major, 3 minor, 4 major, and you can modify that as needed. But you know, this is the out-of-the-box policy. And then in the format section, we have class name alert. We're going to create it as an alert, and you can see, you know, a lot of these mappings just kind of make sense. We have the summary attribute of the Nimsoft alert maps to the summary and of the SOI, and the same for message. And I mentioned how we use the NIM ID to do MDR element ID. And so that's basically it. That's really the whole alert event class.
Hey, Kevin, just a reminder, we've got about 20 minutes left.
Okay, thanks, Stephen. So yeah, I'm going to wrap up in about 1 minute, and then I'll pass it off to Dan here. But I just wanted to let everybody know that we do have inbound connector operations, so we do have the ability to clear alerts within UIM when alerts are cleared within SOI, and this is nothing new to the UIM connector other connectors, you configure it the same way, but you want to make sure the is remotable option is checked here. You also want to enable alert synchronization, and you can do that through the SOI UI. And finally, within the Catalyst registry, we want to enable that synchronization policy, and you can do that just by logging into the Catalyst registry and making that update to the alert filter file. Those three points are what needs to be done. And finally, I just wanted to share some debugging information, where to look for log files, and more importantly, how to enable logging for some additional information. So we have the integration services wrapper, IFW log, and the Nimsoft connector log. So to enable IFW logging, everything's done through the log4j.xml, but there are a few. So here's the path to the IFW log4j.xml, and then we have the Nimsoft connector -log4j.xml, and this enables debug to the Nimsoft connector log. Additionally, we have the log4j-ei.properties, and this is a Catalyst logging, so different than the IFW connectors, where we basically have another level above the IFW that intercepts the raw messages and does some transformation before passing it on to IFW. So if you want to see that, you can enable debugging through that log4j-ei, and here's a screenshot of just where to do that for your reference and review. And now I'm going to pass it on to Dan to talk about what he's done with the UIM connector at AlphaServe. So thanks, Dan.
Cool. Thank you, Kevin. You guys can hear me, right?
Yep.
Yes. Okay. Cool. So thanks, Kevin. Hi, my name is Dan Blanco. I work for AlphaServe Technologies. We're an MSP here in New York City. So yeah, and we were an early adopter for the UIM connector for SOI. So basically, we wanted to implement the connector because we have a broad, CA product portfolio. We have a Spectrum, eHealth, Nimsoft, NFA, UIM, and then when we implemented SOI, we wanted to make SOI our single unified alarm console for our NOC. So, because previously our NOC was looking at both consoles, Spectrum and Nimsoft, to deal with both the network alarms and system alarms. So we implemented SOI, and then we kicked off with the Nimsoft connector, the UIM connector, to have a single unified alarm console. So in doing so, initially when we started off with the connector, there were some things that it was lacking. It didn't bring over all the attributes from the UIM alert properties that we needed present on the SOI console for our NOC engineers to easily make the switch from Nimsoft to SOI. So before diving into the actual policy, this is our SOI setup. We have a distributed setup. Each box, has running its own UIM dedicated connector connecting directly to the Nimsoft primary hub. So we have the manager, the SOI UI, database reporting server, and then we have 3 connector boxes, 3 Spectrum landscapes, and then 1 UIM connector connecting to the primary hub within our environment. So, working with SOI previously, I knew about the service definition policies where you can create services based on certain criteria that the CIs possess. So knowing this, what I wanted to do was when the connector starts up, it imports all the CIs from Nimsoft. So I wanted to make use of the origin property, which correlates to the hub name, which correlates to the actual client name. So when the connector started up, I wanted to populate all the CIs that are from Nimsoft. I wanted to populate the named alias property with the actual client name, which is actually, equal to the hub, which is equal to the origin that's extracted from the Nimsoft database. Doing so, I could then easily create a dynamic service policy that could say, group all computer systems that, where the named alias equals a particular client. And then thus, I wouldn't have to manually create a service within SOI to represent all the CIs that were imported over from the Nimsoft side. Creating this one service, I could usually, knock out a bunch of clients and have a view that represents all the CIs that are being monitored in Nimsoft within SOI. So to do this, actually, if you open up the connector policy itself, you open up the location, and in the let's see. So in this section, under the event class type of item and computer system and generic IP device, I added the following line where, field conditional origin. So we're going to populate the CI's named alias property with the origin. That's pulled in from the Nimsoft database, and that'll populate the CI will then have the client hub name associated with it. So then I could do that query that I explained before. I can create a dynamic service and have all the CIs for that client in one service view within SOI. Additionally, so when the NOC engineers are looking at the UIM console, they can understand, they can see the probe, the hub, the robot, et cetera. They understand the console. Looking at the alerts out of the box for the SOI connector, you don't get a good idea specifically where this alert is coming from. From an MSP perspective, we're looking at multiple clients who have devices in many different locations. So we needed a way to quickly help the NOC engineers identify which client this was coming from, which robot, which probe, which subsystem. So what I did was I made use of the user attribute 1 and 2 columns within SOI, and I mapped the origin, which will tell the NOC engineer which client this alert is coming from. And then for the alert attribute 2 column, so user attribute 1 column I renamed to client name. User attribute 2, I renamed that column to, I called it Nimsoft address. So if you're familiar with Nimsoft, the structure I constructed within the alert, we have the domain, hub, robot, probe, and then subkey, which refers to the probe's subsystem that it's reporting on. So when the alert gets passed over, this is what it looks like on our console. So in this example, I renamed, there you see the client name. You could, a NOC engineer can look at this could say, oh, this is from client such and such. And I know exactly which machine it's coming from, the IP address of the machine. And then in the Nimsoft address, if, you see exactly which client, the robot, the probe, the hub, robot, probe, and then subsystem that's being alerted on. I saw a comment in the questions before regarding how does the UIM connector handle RSP probes or remote probes. Basically, when an alert is generated, if you implement this Nimsoft address column, you'll see that actually, it's coming from the RSP probe, but in the target or actually the names column, in my cases, what I saw, it shows the IP address of the target machine. It didn't contain the actual remote system host that was triggering the alert, but it did display the IP address of that. So there might be additional tweaking to the policy that might be able to, populate the host name instead of just the IP address. So, and coming off of here, once you have the Nimsoft address, if the NOC engineer needs to actually jump into Nimsoft to dive deeper and further, they could decipher the Nimsoft address column. So they could jump into the UIM console and check out, all right, it's this domain, this client, this robot, hub, probe, and then jump into the probe to see additional configuration if it's a valid alert or debug it more. And then from there, take it to the next step with it, open up a ticket with the client and, resolve the issue in a professional manner. So another thing I did with the connector, which was kind of cool, was with the right-click menu entries within SOI, I created a new entry where it automatically, by right-clicking on an alert, or if the CI was modeled within a service, you can right-click on that particular host and bring up a Nimsoft 24-hour UMP summary report, which over there, it'll bring up launching context to the UMP page, showing a PRD report. And, a NOC engineer could submit this report along with a ticket to the client to show them, at this point in time, this is when the alert generated, and you could see, in history what's going on with the box. And this has been very helpful with our NOC engineers in getting issues resolved with our clients much quicker. And, afterwards, I just created this service view. This is called, I created this service, for the team here that deals with all the CA tools. I created this service view. It shows us, I grouped all the sub-products that we have, Nimsoft, eHealth, Spectrum, and SOI, into the respective machines. And this is a great view where, any critical alert that gets generated against any one of these boxes, I have a escalation policy in SOI that sends an email to the entire team. The respective product owner sees the alert, they take care of it already, they take care of it quickly, and it gets resolved. This has been very useful and helpful in, maintaining a proper functioning environment. So yeah, we find SOI, perfect adaptation to our environment, and the NOC engineers, they're getting used to it, they're liking it, and yeah, so, and yeah, that's kind of just a summary wrap-up of what we've done with the Nimsoft Connector Policy.
Awesome.
Thank you, Daniel.
You're welcome.
Mackenzie, can you please open the line for questions?
Yes, ladies and gentlemen, as a reminder, if you would like to ask an audio question, please press star and the number 1 on your telephone keypad. Again, if you would like to ask an audio question, please press star and the number 1 on your telephone keypad. We'll pause for just a moment to compile the audio Q&A roster.
And it looks like we've had more than a dozen questions as well through the Q&A and the WebEx. Thank you very much, Mitch, for handling a lot of those. If Daniel or Kevin would like to look through those as well and see any that they'd like to comment on further, or Kevin, if you have any additional things you'd like to mention, feel free as well. We've still got some time left.
All right, Stephen, since there's no additional questions, what I'd like to at least mention is that our next office hours is scheduled for January 27th at 10 a.m. This is a great opportunity to get onto a WebEx chat and ask questions to our support team. This WebEx was recorded, so if you'd like to have a replay of the recording, you can go into the community by tomorrow and pull that down. Also, questions that have been asked in the Q&A panel will also be posted to the community, so if you'd like to have a look back into that, you can as well. That concludes our presentation for today. I'd like to thank everyone for joining. Would also like to thank Kevin for his presentation today, as well as Daniel Blanco. Thank you very much. Have a great day, everyone.
Thank you.